So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mask coder, and we are going to discuss the question make array elements unique. This is a new POTD. So what does the problem say? The problem is actually very simple. The problem statement say that you can see an array in front of you. What is your array? 9 6 9 8 9 1 2 5, right? It wants that this array contains all unique elements. Contains all unique elements. Currently, you can see that 9 is occurring thrice, and also okay, only 9 is occurring thrice, right? Let me add a 6 also here. Right? Let us see 6 is also there. So 6 will occur twice, right? So it does not contain all unique elements. It contains some duplicates, right? I want to remove those duplicates. Now, how to remove those duplicates? So it is giving me a method. It says that I can increment an element. I can increment the elements. Increment the elements. It only says that I can increment. It does not say anything about decrementing any element, right? I can increment the elements. Alright, if I can increment the elements, and what does that mean? It says that if you encounter a 9 and you want to change it to 11, for example, if you found a 9 and you want to change it to 11, for example, then you will require two operations, that is 9 to 10 and 10 to 11. That is, for each increment operation you will require an operation, right? For each increment you will require an operation, and you have to return me minimum number of operations to achieve this minimum number of increments. I hope the problem statement is very clear to you, right? So what do you have to do? That is clear to you. How do you have to do? Let us explore that. So 9 6 6 9 8 9 1 2 5. I can only increment. I cannot decrement. Please focus that I cannot decrement. The problem changes there. I cannot decrement. I cannot decrement. Right. So how did I process this question? How did I process this question? First of all, rule out the method of decrementing, that I cannot decrement it. Okay. Now what can happen? Let us take an easier example. For example, I have taken 1, 2, 3, let's say 3 again, and then let's say 5. Right. So what is going to happen? This is a sorted array. First of all, I have taken it in form of. Now, because I can only increment, this number can never be can never be smaller than this, can never be larger than this number, because it's a sorted array. First of all, right? My thinking process was that if I sort this array for once, right? So what will happen? This will look something like this only. Now, I'm standing at 2, for example. I'm standing at 2. What can happen? Let us say this is ith element. So ith element can be lesser than I minus 1th element. Ith element can be equals to I minus 1th element. Ith element can be greater than I minus 1th element, right? For example, if this is the condition, which is the condition here, 2 is greater than 1. So is 1 affecting the position or affecting the value of 2 in any way? No, right? Because 2 is greater than 1, so duplicacy is not there, uniqueness is there. If I come here, again, this case only, if I come here now, I can see that it is equal. It is equal. So what now? What now? If 3 3 is there, I can increment thing. I can only increment. So what will I say? I will say just use an operation and change it to 4. Use an operation and change it to 4. In the case of this, use an operation. Use an operation. Right? How many operations? Use one operation, right? 3 to 4, right? No problem. I comes here again this case, right? But what if it was something like this? 1 2 3 3 3 3 5. Okay, I is here nothing, because previous element is nothing, so it is not getting affected by any of them. I is here, 2 is greater than 1, again this case. I is here, 3 is greater than 2, again this case. I is here, now 3 is not greater than, it is equal. To maintain the uniqueness, I will have to increment it. So increment it to 4. You used one operation here, right? I comes here. Now, this 3 actually has become less than 4. This 3 has actually become less than 4. That is not acceptable. This has to remain in sorted order only. So what will I have to do? I will have to change it to 5. I will have to change it to 5. Okay, if I change it to 5, now you will say that if you change it to 5, then this 5 becomes duplicate with this 5. Okay, I say that let us rule that out of the head right now. We will see that afterwards. For current reversion, for this subarray, 5 is greater than 4, right? How many operation did I use now? How many operation did I use now? So I used, 3 to 4, 4 to 5. I used 2 operations here. Now, again, here, 3 is again less than 5. So change it to what? Change it to 6. Because if you change it to 4, not gonna work. If we change it to 5, not gonna work. What I'm doing is I have to maintain uniqueness from 0 to I. Maintain uniqueness from 0 to I, right? I comes here, change it to 6. How many operation? 3, 6 minus 3, that is equals to 3 operation. I comes here, now what do I have to change 5 to? I will have to change 5 to 7. I will have to change 5 to 7 to maintain the duplicacy, because 6 is the lowest character I know, and 6, it has to be greater than 6. So 6 and anything less than greater than 6 is 7, right? Okay, so it takes how many operations? 2 operations. So what is the answer? 1 plus 2 plus 3 plus 2, that is equals to 3 plus 3, 6 plus 8, that is equals to 8 operation. That is your answer. What we have done, procedure is very simple. Sort the array, right? Second step is for I going from 1 till n minus 1. What will happen? The condition is if my array I is less than equals to my array I minus 1, in that case answer plus equals to array I minus 1. This is my target value and this is my initial value. This is the like answer I equal to 0 I have initialized here. This is my target value and this is my present value, right? We have to take the reference only, right? And then now change it. So array of I will now get changed to target value only. The array of I minus 1 minus 1, right? And at last return array answer. Return answer. See, we have to do this only in the case of this. It can be that 1, 3, 6 is present. So 3 is not getting affected by 1, 6 is not getting affected by 3. Only in the case of equality or lesser than inequality, we will have to use this. So we are using this if statement, right? What is the time complexity? So sorting requires n log n time, and we are not using any extra space, and we are just traversing. So it is O of n log n for time complexity, and O of 1 for space complexity, and very easy, right? Very easy. I don't think that this is of the medium category question, right? So let us now move to code. Here is the coding section. Let me write down the code real fast. So sort the array first. Sort array dot begin, array dot end, right? Array sorted. Now take your answer equal to 0 right now because no operations. Now for end I going from 1 up till the last of the array, right? What will you do? If my current element is lesser than equals to my previous element, in that case answer will get incremented to array I minus 1 plus 1. This is my target value minus array I. This is my current value, and also array I will get changed to my target value, right? Now return your answer. Let me write down the code. Let me run it for the sample test case. It is running fine for the sample test case. Hope it will run fine for the hidden test cases as well. Okay, getting accepted. So thank you for watching. Hope you liked it, and make sure to like and subscribe to the channel so that it gets a better reach and I am able to help more people. Right. So thank you and stay tuned.